Hello and welcome all on Unacademy JEE English, a channel launched by Unacademy where each and every topic of JEE will be covered in pure English. And not just JEE Main, we are going to teach you of the JEE Advanced level, right? So today I am Rahul Kaushik. We'll take periodic table and periodicity properties lecture number 8. Before that, we have already covered 7 lectures. But before I start anything, let me introduce you a brief description of me. Yes, I'm Rahul Kaushik again. I was head of department in Bansa Classes Kota. I worked there since 2010 to 2020 and I mentored 2000 plus IITs there. Right, 2000 plus IITs. After that, I co-founded my own organization, Zigyan Education Private Limited, and now I'm here on Unacademy, India's largest and fastest growing online platform. So guys, let's crack it. So how you guys can become part of Unacademy? Just go to App Store or Play Store, download Unacademy Learning app. Once you download it, install it, and after installing, you have to just click on the plus. Once you click on the plus, you will be directed to certain courses, like in this case IIT JEE NEET. You have to click on the IIT JEE because it is exclusively for IIT JEE, and then click on the get subscription. Once you click on the get subscription, you will be directed to a page where different options will be there. For 1 month program, it has 6,000 per month subscription charges. For 3 months, it has 5,000. For 6 months, 4. For 12 months, 2,400. But for you guys, as I am teaching today periodic properties for 2022, so for you, this is the best package, and you just have to pay 1,500 rupees, guys. Just imagine 1,500 rupees, 50 rupees per day, and you are going to get access not to just me and my content. You are going to get access to the content and lectures of all senior educators across India. Now all senior and best educators are on an Academy learning platform, almost from every part of India, right? So over and above, if you apply my code Rahul Camp, then you are going to get extra 5,400 rupees, right? So if just remember this code, you are going to get 5,400 rupees for it. And now this is all about subscription. So let's begin. Periodic table and periodicity in properties lecture number 8. So let's crack it. So previous recap. Now onward, I'm using these icons. Maybe do you like it? Okay. Hi Captain. Hi Priya. So Captain, you are on time. Yes. So let's start. In previous year we did electron affinity, and I told you what is electron affinity. Basically every atom has some tendency to gain electron except certain other atoms, which I have discussed: nitrogen, second group element, and 18 group element. Except these, all others have some tendency. So when they accept one electron, during this process some energy will be released, and this energy is called electron gain enthalpy. This energy is called electron gain enthalpy. So to remove some misconception or some misunderstanding, we have defined another term, that is minus of delta EGH. So electron affinity will be 100 for in this case. So if in some case delta H is minus 200, so electron affinity will be plus 200. Now I can say this affinity is more. Affinity means love, attraction. You guys understand love. So attraction. So here affinity is more means attraction is more. Here attraction is less. Because this is confusing, minus 100 or minus 200. If you take it with sign, then which one is larger? Minus 100. Without sign, 200 will be larger. To avoid that misconception, we have taken it. So I told you that second electron gain enthalpy of every element will be negative, because once it becomes negative, it does not want to absorb one more electron. And if you do so, you have to do it forcefully, and while doing forcefully, you have to provide extra energy. Any doubt? Any doubt, guys? So this was what we did in the last class, and I told you just note down these points. Now just remember this symbol. Wherever you found this symbol, it means you have to note it down. You are not going to find it anywhere else. We are working very hard to arrange all these things for you guys. So these are the elements which have negative electron affinity, means they don't want to accept electrons at all, right? They don't want to accept electrons at all. They are not going to gain. So what is it? Second group, 18th group, nitrogen, zinc, cadmium, mercury, pseudo net gas configuration, and hafnium. I hope you got my point. Got it? So let's move. Now periodicity of E, we discussed this thing also. As we move down, the group size increases. As a result, tendency to accept electron decreases. But when we move left to right, now this nitrogen was exception. So left to right actually symbol is this, but in case of nitrogen, here symbol is reversed. Carbon has more because nitrogen has exactly half-filled electronic configuration, right? So this is periodicity, and I have made the complete table. I hope you have noted down. Any doubt? So the third period element has higher electron affinity than the second. This thing I told you why this is so, because second period size of second period element is small, and if you add an extra electron, then the repulsions will be very high because electrons will be accommodated in second orbit and there is no vacant d orbital, so repulsion will be high. While we add, in case of third period onward, we have 3d 4d vacant d subshells, so electron can be delocalized and it is free to move in vacant d orbital, so it will stay there, and by doing so it will reduce repulsion. Is that right? So now find least and maximum electron affinity. So I think this problem was discussed. If not, then solve it again. I just told you how to solve such problems. Just arrange them according to their position in periodic table. Now I know chlorine, sulfur. So the maximum electronegativity will be chlorine. So basically in periodic table, chlorine has maximum electron affinity. Chlorine has maximum electronegativity. Very important point. Note it down. Chlorine has maximum electronegativity. Got it? Yes. So now maximum is chlorine, so what will be the minimum? So you can see here oxygen will be minimum. So it is done now. If you arrange them, it will be chlorine, then fluorine, then fluorine and sulfur. It will be difficult, so don't compare, you just have to see. IIT is never going to ask any such problem where data is involved, rarely, and if it will ask, then it's very difficult to answer. So for one problem, don't waste too much time, don't remember unnecessary data. Now the points start. Next subtopic I'm going to start is electronegativity, and guys, it's very important. It's very important because this topic is going to help you a lot in throughout the chemistry. You will encounter this. What is electronegativity we will discuss, but before that my first question is how molecules are formed. Tell me how molecules are formed. Any answers? So let me tell you, suppose this is atom hydrogen, it has only one electron. When H2 is formed, you might have learned in your 10th class, these two hydrogen will share electrons. By this way, by sharing, it will complete its octet. and we denote it like this. If I'm taking oxygen, it has 6 valence electrons. It has 6 valence electrons. Now O2, what is that O2? 1, 2, this. Now it needs 2 electrons, so it will share now like this. In above case there was only one pair, here we have 2 pairs, 1 pair, 2 pair, right? These pairs are called lone pair because they do not participate in the bonding, and these pairs are called bond pair. So how will I denote it? O double bond O. And now if I move to nitrogen, so it will be, now it needs 3 electrons, so it will share 3 electrons, and I will denote it like this. Now the point is that these electrons are shared in between them. Here it is shared, here it is, these are shared. So when I am talking about hydrogen, it means what is hydrogen? It is 1 electron, and there is a positive charge nucleus at the center. And there is a positive charge nucleus at the center. Now what will happen? That positively charged nucleus, now these 2 electrons are shared, but these shared electrons are attracted by, this positively charged sphere and this as well. So this nucleus will attract both electron. Basically shared pair of electron will be attracted by this and this. And here it is hydrogen, so it is like tug of war. And if 2 equal competitors are there, both have hydrogen, then both will pull it with the same force, and the net resultant will be 0. Electron will be here only at the center. And I will denote it like this. These 2 dots are nucleus, and if I want to denote electrons, those will be at the center. In this case also, again tug of war is between OO, so equal in strength. If they are equal in strength, it means again shared electron will be just at the center. Now again if I take nitrogen, both are equally strength, so again shared pair will be at the center. So shared pair will be at the center, it is not tilted towards any particular atom. Why? In all these cases, what is happening? In all these cases, the nucleus is equally strong in case of hydrogen, oxygen, because both are same. But what will happen if I make a bond between hydrogen and fluorine? What will happen? Hydrogen has 1 electron, fluorine has 7, like this. So now if I make nucleus of this and nucleus of this, so let me tell you one point, and it is very important point. It has only 1 proton and it has 9 proton, and suppose electrons are here. Now which nucleus will attract shared pair of electron more strongly? Tell me. Which will attract shared pair of electron more strongly? Tell me. Is it hydrogen or is it fluorine? I just told you hydrogen has only 1 proton in its nucleus and it has 9. So 9 proton are pulling, and one side only 1 proton is pulling. So which will be stronger? Jack says F. Yes. So fluorine will attract it. So in this case electron cloud was at the center, but here electron cloud will be pulled towards fluorine. As a result, there will be partial negative charge on fluorine and there will be partial positive charge on hydrogen. and there will be partial positive charge on hydrogen. So do you have any point, guys? Any point, any question to ask? No. So let's move it. This is what I have shown: double bond, triple bond, lone pair. What is lone pair? Now I have told you. Here we have only one bond pair. Here we have two bond pair. So we denote it by double bond, and such bonds are called covalent bond. Here sharing of electrons takes place, and the bond formed by sharing of electron is called covalent bond. I hope it's clear. Clear? Yes. So what is electronegativity? So now let's take this HF example. So hydrogen and fluorine. In ideal case, this electron cloud should have been at the center in ideal case. But I just told you it has 1 proton and it has 9 proton. Now what will happen? These electrons are attracted towards fluorine. If these are attracted towards fluorine, and fluorine will attract them by a large force, so this cloud will shift towards fluorine itself. So fluorine will have partially negative charge because electrons are negative and they are close to fluorine, and then it will have partial positive charge, equal in magnitude. I am here making partial positive, partial negative, partially ionic, right? So what is completely ionic? So let me tell you. In case of NaCl, what happens is nitrogen loses 1 electron completely by ionization, and then chlorine absorbs 1 electron again by electron gain enthalpy. So when you add them, you are going to get Na plus Cl minus. They attract each other and bond is formed. So the NaCl formed is called pure ionic, because here completely electron is lost by one completely and gained by another. So I'm writing here +1 and -1. But here electrons are lost by none. Nobody has lost electron, nobody has gained. It is like a marriage. Like I have 2 electron, you have 2 electron. I say you call it yours, I will call it 2 electron mine, and both are happy. These are yours and these are mine. This is exactly what's going on. So now if I consider charge on fluorine, it will be partial negative and it will be partial positive. I hope everything is clear now. Everything. So now you understand the meaning of partial ionic and complete ionic. In complete ionic, complete transfer of electron will take place. Now here if complete transfer take place, then I will write H plus and F minus, not delta. So it is showing. Now if there is just transfer, not complete, then I will call it partial ionic. So guys, always you should have a pen and pencil with you, pen and copy. If you are studying without pen and copy, it means you are wasting your time. Just note down everything. I am just teaching you the way I teach in the class. So what is electronegativity? Now let's come to this point. Till this point I told you how to make molecule, how electrons are shared, what is covalent bond, what is ionic bond. We have discussed everything, and now I'm going to tell you the electronegativity. This concept was proposed by Linus Pauling in 1930. 90 years back. Think how smart he was. But we are studying it today. He taught it, he discovered it 90 years back. What he said, what is electronegativity? It is tendency of an atom to attract. Shared pair of electron. Very important point. Students often miss it. It is tendency of atom to attract shared pair of electron towards it due to difference in Z effective values. Why those are attracted? So let me tell you, Z effective. I told you wherever Z effective is written, consider that attraction. Wherever Z effective is given, consider that attraction. Right? So if it is attraction, in case of H2, both have same Z effective. Here both have same Z effective. Here both have same Z effective. Because atoms are same. Atoms are same. But when I am taking hydrogen and fluorine, I just told you here we have 1 proton and here we have 9 proton. So attraction will be more in this case fluorine. So I will say Z effective will be high in this case. And if Z effective is high, what will happen? If Z effective is high, it will attract electron to a larger extent. Okay. It will attract electron to a larger extent. So why electrons are attracted more towards F? Because it has high Z effective. If this and this have same Z effective, then electrons will be at center, and that can happen only when, if it is hydrogen, it should also be hydrogen. If these two are different elements, then definitely they will have different number of nuclei in their nucleus. So Z effective cannot be same. If Z effective is not same, then electrons will be attracted towards one side, and the side which attracts electron will get partial negative charge and the other will get partial positive charge. So this is what it says. So shared pair of electrons should be attracted. We are not talking about lone pairs. Lone pair I just told you. So again read it. It is tendency of an atom to attract shared pair of electron towards itself due to difference in Z effective value of atoms. Just ask if you have any doubt. Hi Manish. Very important topic is going on and I hope you guys are enjoying it. Yes. Tell me. Any doubt? Hi Monica. Hi Priya. Captain. Any doubt you are facing? I hope you guys enjoyed yesterday quiz. Did you really enjoy it? Yes, tell me. Okay. No? Okay, you are giving the answer of previous question. Yes. So let's begin. Okay. No doubt. So Manish, Monica, Captain, let's move ahead. So now you understand the electronegativity. So today class onward I will use these icons. If somewhere it means some discussion is going on. Some questions should be asked, which generally I ask. I know what kind of question are going to come in your mind, and if something like is there, question and answer, and if something like is there, it means these are key points. You have to note them down and remember them. Key points, right? So what is electronegativity? Tell me. What is electronegativity? So it is property of an atom in bonded state, not in isolated state. I just discussed this point. It is property in bonded because shared pair. So where will the shared pair of electron come? Shared pair of electron will come only when bonding takes place. Only when bonding takes place. I hope you got my point. Now again it represents tendency to attract shared pair of electron. So it is shared pair and it is always in bonded state. Whenever we talk about electronegativity, it should be in bonded state. Okay, let's move ahead. So what are the factors on which electronegativity depends? So first one is Z effective. So if Z effective increases, what will happen? Attraction will increase. And if attraction increases, more electrons will be attracted. So as Z effective increases, electronegativity increases. So when we move left to right, electronegativity will increase, because while moving left to right, Z effective increases. Z effective simply represent force of attraction. Z effective represents force of attraction. I hope you got my point. Is that done? Yes. Now, what do you mean by size? If size increases, then definitely, if nucleus is here, first shell, second shell, third shell, fourth shell, if fourth shell is taking part in bonding, then distance from nucleus will increase, and if size increases, then tendency to attract will also decrease. So as size increases, electronegativity will decrease. Now repulsion, so you can easily understand, as repulsion increases, so repulsion means it will repel electron, then why will it attract? So more the repulsion, less will be the electronegativity, so it is inversely proportional to S. I told you, always consider S as repulsion. It is screening constant, screening effect. You should always consider it as repulsion for feeling, so that you can feel what is S. As I say, whenever Z effective is given, always consider it as attraction. Always consider it as attraction. Right? So now 3 points are clear. So what are other factors on which electronegativity depend? So let's see. It also depends upon oxidation state. So what is oxidation state? This is neutral nitrogen. After losing one electron, 1 plus will come. After losing 2 electron, 2 plus will come. And after losing 3 electron, 3 plus will come. So number of electrons are decreasing 6, 5, 4, because this. Bolo. So here we have 7 proton. 7 proton are attracting 7 electrons, and here these are attracting 4 electrons. Now what is going to happen? Yes, tell me. So here 7 protons are attracting 4, so Z effective will be maximum. This is also called oxidation state. What is oxidation state? We will deal it in detail in redox. But in 10th class also you guys have done it. I hope in 9th class you guys have done it. Oxidation state. No. How many of you have done it in 10th class? Please tell me. How many? Yes. So, no. Actually, removing of hydrogen, it's okay, but in redox we will learn it in detail in the latest convention. We take oxidation or reduction by number of electron. Removing an electron is called oxidation. Let me write it. This is oxidation, and gaining an electron is reduction. So now we answer it in terms of electron. You are also right. I will take all these things. So electronegativity depend upon the oxidation state. As oxidation state increases, electronegativity also increases. Note it down. Now tell me, Cu and CO2. There is carbon in Cu and carbon in CO2. Now which will have higher electronegativity? Tell me. Which will have higher electronegativity? Yes. Tell me. Why CO2? Yes, Captain Jack. Why CO2? Tell me the answer. I'm waiting. Why this is CO2? Okay, let me tell you. If you calculate oxidation state of this, it is +2. If you calculate oxidation state of this, it is +4. So this is +2, this is +4. So oxidation state of carbon in CO2 is more. So in this case, so here one point is clear, like if I am writing C, it is having different electronegativities in different environment. If environment changes, electronegativity of also C also changes. So this is the case not with just C, with every element. Its electronegativity is not fixed. Like if I'm taking fluorine with hydrogen and I'm taking fluorine with nitrogen, then the electronegativity of fluorine will be different in both cases. It changes as the environment changes. Very important point. Electronegativity is not fixed. Actually it depends, because it is relative term. It is always calculated in bonded state. So once you are connecting it with hydrogen, electronegativity is different, because hydrogen and nitrogen have different nucleus. Here nitrogen is pulling, here hydrogen is pulling nitrogen. Obviously it will pull more strongly as compared to hydrogen. Why? Why? Because it is having 7 proton and it is having 1 proton. Now I hope you understand the point. Yes, I hope you understand the point. Now answer it. In this nitrogen, in this nitrogen, which is having more electronegativity? Tell me. Yes, I'm waiting for your answer. Quick, quick. Repeat. I was telling, here it is HF, here it is NF. So fluorine has common nucleus and these are shared electron. Here both are attracting, here both are attracting. Hydrogen has 1 proton, nitrogen has 7 proton, fluorine has 9 proton here as well as here. So here nitrogen will pull them more strongly as compared to hydrogen, because Z effective of nitrogen is more. So tendency of fluorine or electronegativity of fluorine will also be different here and here. Got my point? So tell me, NO and N2O5, in which case nitrogen have more electronegativity? Calculate it. Yes, calculate it. Quick, you can do it easily. The basic oxidation state calculation. Yes, yes. Captain Jack says N2O5. Yes. Now if we calculate oxidation state here, it will be X plus -2. So oxidation state of nitrogen is +2 here. But if we calculate oxidation state here, it is 2x plus 5 into -2. So x will be +5. So here it is +5. So it is plus. So I just told you, as positive oxidation state increases, then electronegativity also increases. Yes, it will be N2O5. It will be N2O5. You got it right. Right? So let's move to the next point. Now note it down. Electronegativity of element changes with change in environment or the change in oxidation state. The point I discussed. The point I discussed. Any doubt? Any doubt? No doubt? Okay. So now I'm taking factors affecting electronegativity, point number 5. Actually, electronegativity increases with increase in percentage as character. Actually, right now, if you have just completed your 10th class, you will not understand this point, because how to calculate S character, you can do it only after chemical bonding. So I'm just giving you idea, and once you do chemical bonding, just note down this point in your copy, and at that point of time you can see what's wrong with it. So here we have C single bond C, double bond C, triple bond C, CH2, this. So I want to tell you, actually you have to just listen it, because you can't understand right at this point. If somebody is from 12th class, he can easily understand. So this is sp3 hybridized, this carbon is sp2, both, and this is sp. So here there is 1s 1p, here it is having 1s and 2p, total 3 orbitals. So percentage s here will be 1 by 2 into 150%. Here we have 1s and 2p, total 3 orbitals. So it is 33.3%. Here we have 1 by 4. So here it is 25%. So now S character is maximum here. And if S character is maximum here, then I can say electronegativity of this carbon will be maximum and this will be minimum. So how these calculated, sp, sp2, sp3, this will be done in hybridization. So don't worry about it. Don't worry. Right? You got it? Now, how measurements of electronegativity are done? Actually, there are basically different methods. One is Pauling scale, another is Mulliken scale, another one is Eldred-Roscoe scale. Right? But the general method we use is Pauling scale. So you don't have to go into the details, because NCERT don't have these details, so IT is never going to ask. But you should know the basic idea behind these scales. So the Pauling scale, it is based on bond energy data. Mulliken scale is based on ionization energy and electron affinity data. You must know these things. Must remember. Eldred and Roscoe, it is based on electrostatic attraction. It is based on electrostatic attraction of nucleus and electron. Right? So there are 3 scales, but right now we are going to take one, because generally problem is asked from Pauling scale only. Mulliken and Eldred are not there in NCERT. Yes, any doubt? Please ask me. Yes, Captain. I do not understand, sir. What? Which point? Actually, I just told you, you are not going to understand it. You will understand it once you will study chemical bonding. So just note this point down, and after chemical bonding, read it again. Then you will understand it. I just told you, at this point of time, it is very difficult to make you understand, because you don't know what is hybridization, what is sp, what is sp2. Just forget about it. Right? Here we have just done percentage S character. As percentage S character increases, electronegativity increases. That's it. Right? Any doubt? So now Pauling scale. So this scale is based on bond energy data. This scale is based on bond energy data. Now characteristics of Pauling scale. On Pauling scale, electronegativity of inert gas is taken as 0. Yani helium, neon, argon, krypton, xenon. These have electronegativity of 0. Why? Because these do not form bond with anyone else. So how will they attract? So he considered, actually 1930, there was no known compound of these elements. So these were considered as inert. Right now you people know xenon forms many compounds, but in 1930 there was nothing. So he considered their electronegativity as 0. And he said because it is relative. The fluorine, when it is connected to nitrogen, will have different tendency, different with attracting electron with different force, as compared to the same fluorine when it is connected to nitrogen, right? So fluorine is considered as most electronegative element. Fluorine is most electronegative element, means with whatever element it is connected, fluorine will always attract electron towards it. Fluorine will always attract electrons towards it. Any doubt? Please tell me if you have any doubt. No doubt? Yes. So just remember it. Wherever you find it, it means you have to remember some important pointers there. So you have to remember these values as well. These are going to help you a lot. So electronegativity of fluorine in Pauling scale is 4, 3.5 and 3, 2.5. Decreasing by 0.5. It is easy. And hydrogen you have to remember 2.1. And hydrogen and phosphorus has same. And there is one more point. Sulfur has more electronegativity than carbon. Many a times this thing will be asked. Very important. You got it? Tell me. Any doubt? No doubt? So remember it. Remember it. I'm telling you over and again. Hydrogen and phosphorus has the same 2.1. So let's move to the next point. Now write down variation of electronegativity. So point number 1, in a period. So when we are talking about a period, it moves, it means we are moving left to right. So when we move left to right, what will happen? Z effective. What will be the effect on Z effective? Z effective will increase, and if Z effective increases, it means force of attraction will increase, and if force of attraction increases, it means size will decrease, and if size decreases, so attraction will be more attraction because electrons are coming close to it. This means electronegativity increases. So you just go stepwise. Like you can take carbon, nitrogen, oxygen, fluorine. It has 4. It is increasing. There is no exception here. Just note it down. Now let's talk about in a group. In a group. What will happen when we move top to bottom? Like fluorine, chlorine, bromine, iodine. So you can easily understand when we are moving top to bottom, size is increasing, and if size is increasing, then force of attraction will decrease, and in turn tendency to attract shared pair will also decrease. So I can say when we move left top to bottom, size increases, and this means electronegativity decreases. Any doubt? So it is general trend and we don't have to go into much details of this. Now the point is application of electronegativity. Where do we use it? The first application is it is used to find out percentage ionic character. It is used to find out percentage ionic character of a molecule. How we are going to use it to find out percentage ionic character? So the percentage ionic character formula is 16 into delta X this. I hope you got it. Where percentage IC means percentage ionic character, delta X means electronegativity difference, and delta X we will call chi A minus chi B, mole fraction magnitude of this. What is chi A? It is basically electronegativity of A. What is chi B? It is basically electronegativity of B. We don't call it X, it is chi. It is chi. Note it down. For example, if I ask calculate percentage ionic character of hydrogen, just do it. Yes, I'm waiting for your answers. Solve it. Yes. See, it is hydrogen. So 2.1, 2.1, so delta X would be 0. So percentage ionic character would be 0. It means I can say it is 100% covalent. So something is like acidic basic. If something is 100% acidic, I can say it is 0% basic. So I can say 0% ionic here. Suppose if we have 80% covalent character, then 20% will be ionic. So some will be 100. So here it is actually in this world nothing is perfect. Neither me nor you nor anything. So exactly 100% is not possible. Some polarity is there, but we consider it as 100%. Right? Thank you, Priya. It is not 4 lecture topic. Yes, it generally takes this much time. Thanks a lot. So you people keep on studying it. You are going to get the best out of Unacademy learning platform. Right? So now let's do it for another problem. Now solve it. Find percentage ionic character of NO. Solve it. Solve it. Now you know it has 3.5 and it has 3. So delta X will be 0.5. So percentage ionic character is so what you are going to get? Tell me. It means percentage ionic character will be so percentage covalent I hope you got it. Got it? So now you know the percentage ionic character of NO. right? Here it is tightly ionic. So here I can also say this is delta negative, this is delta positive, not one positive or one minus, delta partially. And you know why I'm saying it. So in case of hydrogen, I will call it non-polar, but this compound is polar. Why this compound is polar? Why this compound is polar? Because positive and negative, two poles are created. Because positive and negative, two poles are created. I hope you understand this point. So this is non-polar. So now you can find out like H2, O2, N2, P4. These are all non-polar compounds. Why? Because they have same electronegativity of both combining element. So no charge will be created on any atom. But HF, H2O, NO, etc. These are all polar. And what do you mean by pole? Like North Pole and South Pole. Here we have positive and negative. I hope you got my point. Here we have positive and negative. Any doubt? Please ask. Okay. Now, application number 2. Application number 2. Audition, you don't need any new book or anything like that. Actually, whatever we people teach, generally we take it from 4 to 5 books. So it would be better if you follow NCERT properly for inorganic and just follow our notes and practice material of any institute. Right? Reading books is very good idea and very good thing. Actually, we people read books. That's why we teach you. But if you want to maximize your effort, it would be a bit impractical. So it would be better if you use any other institute material for practice. And NCERT is the best. If you can read, don't leave a single line from NCERT. And after that, if you can do, then we can discuss what are those books. So now application 2, just note it down. Electronegativity is used to find out acidity order of hydracids. Now what are hydracids? HX. So these are acids which contain hydrogen and another element, and they can give you H plus. So if I say HX, it will give you H plus and X minus. H2Y, it will give you 2H plus or Y2 minus. These are hydracids. So strength of hydra acids depend on two factors. And what are those factors? Electronegativity difference, and second one is bond length. Very important thing I'm going to teach you. Many a time JEE has asked this question. Very important. Hi Kaushik Jain. Hello. Very important thing is going on. So this acidic strength depend upon 2 points. One is called electronegativity difference and another is called bond length. Right? Hi Ujjwal. After so many days you are back. So today I'm going to teach you very important thing. Just focus on that. Don't write any comment. Just focus on that. So strength of hydra acid depend upon two factors. One is electronegativity difference and another one is bond length. JEE has asked this question 3 to 4 times in advance as well. So keep in mind. So the first one is electronegativity difference. So what is electronegativity difference? As electronegativity difference increases, acidity also increases. So if I say HF and HO, in which case electronegativity difference is more? Tell me. That's why I told you to remember the values. In which case it is 2.1, it is 4. So difference here is 1.9 and here it is 0.9. So it is more. It is having more electronegativity difference. So it is more acidic. So you know the acidity order. So I can say if I compare HF and HCl, so which will be more electronegative? Sorry, which will be more acidic? HF and HCl. Tell me. Which will be more acidic? Yes. So just write down the electronegativity values. It is 2.1. And it is 4. 2.1 and it is, what was the value of chlorine? Please tell me. What was the value of chlorine? Electronegativity value? Yes. No answer. Okay, I am showing you again. Remember all these values. It's important. Remember all these values. Yes. 3.2. Just remember these. These you can remember by decreasing 0.5. Just remember these two values. Okay. So now let's solve it. It is 3.2. So the difference here is again 1.9 and difference here is 1.1. So HF is more acidic. So this way you can give the answer. Now let's move to the next point, and that point is variation in a group. Variation in a group. So group means when we are moving left to top to bottom. So let's see. No. Just let me take one more thing. I took electronegativity difference and now bond length. So acidity strength means something that can easily lose H plus is called acidic. More easily it loses H plus, more will be its acidity. So bond length, you know, if I say HF, if I say HCl, if I say HI, so which is easier to break? Like, is it easier to break or it is easier to break? Which one? Where the length is more, it is easy to break. So as bond length increases, bond strength decreases, and this bond can be easily broken as compared to this. So order will be this. So you can write as bond length increases, acidity increases. So HF, HCl and HI, this one is more. Bond length of HI will be most. So if I arrange them, HF, HCl, HBr and HI, so acidity order will be this. Right? So when we are moving left, top to bottom, acidity is decreasing. HI is most acidic. HI is most acidic. Now tell me the order. So I can say in a group, bond length factor dominates. So when you are moving in a group, just answer it with the help of bond length. Gerald, I am definitely going to start a revision series, but that will be on a special and it will be free of cost. So don't worry. Very soon I am going to start in 3 to 4 days. Definitely. There will be a series. So in a group, now suppose if I give you a question. So such problems are asked in JEE. Now arrange them in increasing order of acidity: H2O, H2S. Arrange them in increasing order of acidity, please. Definitely I will be very soon on a special. There are some technical issues, equipment related, so don't worry about it. Yes, arrange them in increasing order of acidity. So basically us, se, ti, po. I'm talking about group and I just told you in group bond factor dominates. So just answer your order as per bond order. So here bond will be maximum length. It is easiest to break. It will give you most easily H plus. So this is your answer. So this is your answer. Right? Now how will you answer? Now there is one more question. Now there is one more question. If I take CH4, NH3, H2O, HF. Now if you compare carbon, nitrogen, oxygen, hydrogen, we are moving in a period. So just answer it. In a period, actually bond length will not change much in a period. Because carbon, nitrogen, oxygen, fluorine, they have slightly different radii. In a group, bond length changes drastically. Why? Because like if it is I take H, I take F. Here it is H, chlorine, H, bromine. So bond length increases. Because every time we are moving downward, one extra shell is added, and due to that shell, what is going on? Bond length is increasing. So here bond length will not change much because all are from second period. So if bond length is not changing much, then in a period, note in a period, electronegativity difference, END, electronegativity difference will dominate. So now see where electronegativity difference is maximum. Tell me where that difference is maximum, electronegativity difference. 4, 3.5. It is here maximum. So HF will be most acidic of these. Right? HF will be most acidic. Now you can answer. Let me take one more problem. If I take now give me the answer. Yes. Yes. Now give me the answer. Yes. Any doubt? So again, silicon, phosphorus, sulfur, chlorine, we are talking about in the same period. And same period I will say electronegativity difference. So electronegativity difference will be maximum in HCl. So order will be this. Yes, Manish, you are right. Yes. So we will stop theory at this point, and now it's time for quiz. Now it's time for quiz. So guys, are you ready for the quiz? So whatever we have learned today, we will take it through the quiz. Yes. Question number 1 on your screen. Just give me the answer quick. Let's see what you have learned. Yes, everyone. Fast, fast. I'm waiting. Yes. Yes, Priya, Manish, Arshu. Question number 1. The formation of oxide O2 minus gas from oxygen require first an exothermic process. Yes, because when oxygen absorbs electron, energy is released. And then an endothermic. Yes, it is basically second electron gain enthalpy. Okay. Thus, the process of formation of O2 minus gas is unfavorable even though O2 minus is isoelectronic with neon. Because now after achieving one more electron, it has become isoelectronic and its configuration is like neon. So it should be maximum stable. So what will happen now? It is due to the fact. Why? Actually, here also energy should have been released, but we have to provide very large amount of energy. Although after getting two electron, it is getting configuration of Ne, and everything want to go or want to achieve configuration of Ne. Got it? So how will you do it? How will you do it? So what is the reason behind it? It says it does not want to accept at all. Although neon is stable, why? Why it is going on? So oxygen is more electronegativity? No. Addition of electron in oxygen result in larger size of ion? Yes, it causes, but is it the reason? No. Electron repulsion outweighs the stability gained by achieving noble gas configuration. Lattice energy of oxide formation compensate the gain during anion formation. Actually, D will be the answer. Right now, let me tell you, when some oxide is formed, so right now if you add them, total energy will be positive. But when this reaction will take place and CO solid will be formed, huge amount of energy will be released, and that energy is called lattice energy. So net energy will be released, and due to this formation of lattice and lattice energy, these oxides are formed. Ideally, oxides should not have been formed. So electron repulsion outweighs the stability gained by. Yes, tell me. Actually, this could have been the answer. Okay. Yes. Actually, here it is not given lattice. It is not talking about the lattice. So we just have to take. So C is the correct answer. Okay. Just leave it. Here in question, if it would have been mentioned, I will take that question in the next slide. Then they might ask why such oxide exist even though O2 production of O2 minus is unfavorable, then why these oxides are formed. I was taking the example of that. So you are right, Harshu and Jack, you are right. Take its example C. Don't worry. Yes, that is true. So now next question on your screen. No affinity for electron. Quickly, 30-second question. 30-second question. Yes, tell me. Yes, Arsu, you are right. Which of the following set of element will have no affinity for electron? Quick, quick. Just tell me. Quick. Yes. Which of the following set of element will have no affinity for electron? So it is this one: helium, neon and calcium. C. Yes, Captain Jack, you are right. So let's move to the next point. All are inert, they don't want to gain electron. Now solve it. In the last class we discussed this thing. Solve it quickly. N losing one electron, chlorine losing one electron. You can also write it like this way. So now tell me, in this process, delta H, sign of delta H. Yes, tell me. Which one is the answer? Basically, ionization of nitrogen and chlorine is taking place, and I told you ionization process is always endothermic. Ionization process is always endothermic. So this will be positive, this will be positive, answer will be 1. Answer will be 1. Yes. So next, which of them is exothermic? Easy question. Which of them is exothermic? I told you whenever attraction takes place, process will be exothermic, and you just have to find the attraction. Nitrogen, no. Here you know it is case of exception, delta H will be positive. Again, 2 electrons are added, O2 minus, no. If one have been there, then it would have been exothermic. No, no. Positive and electron, yes, this is exothermic. So 3 will be the answer. Yes, Jack. Yes, Manish, you are right. Good. Very good. So now the last question of the day. Just solve it. Which of them is correct order of ionization energy? Yes. Solve it. And tell me. Yes. I told you in such case, just arrange them as per in periodic table position. Nitrogen, oxygen, sulfur. I need ionization energy, so nitrogen will have more. Why? Because it is 2p3, it is 2p4. Oxygen will have more. So nitrogen, then oxygen, then sulfur. Now tell me the answer. Yes, tell me. I am not going to solve it. In sulfur and phosphorus, phosphorus will have more. Again, exactly half-filled configuration due to this. So this is the answer. Nobody cares what I'm writing. Nobody. So guys, if you really like this lecture, please like and share it as much as possible. And before finishing this lecture, let me tell you how you can subscribe to Unacademy. Just download Unacademy learning app, click on the plus, and once you click on the plus, you will be directed to these options. Select IIT JEE. Once you select IIT JEE, click on the get subscription, and once you click on the get subscription, you are going to get these options. But for you, this is the best because it is 24-month, and preparing for JEE is not a 1 or 3 month task, and we are doing it for 2022. And if you opt it, you just have to pay 1500 rupees per month, and along with it you will get not just access to my content, but content of all educators, of top educators of country under one roof. And over and above, if you apply my code RahulChem, then you are going to get a flat discount of 5400 rupees. so it will be beneficial for you. So guys, that's it for today, and if you really like this lecture, then don't forget to share and like it and click on the bell icon so that you can get latest notification of my lectures. So tomorrow I will meet you again. For the time being, take care. Bye bye.